We're going to look at an example from your homework. We just covered derivatives of logarithms. And so now we have this example, y equals t times e to the t power plus 2. And that whole quantity I just gave is all over the quantity e raised to the 4t and then plus 3. And it wants us to find the derivative. And so we're using multiple rules of derivatives that we've learned. We're using the quotient rule. When we take the derivative of the numerator, we're using the product rule. And when we take the derivative of the denominator as part of that quotient rule, we have to use the chain rule on that e to the 4t. Let me just kind of write down our rules really quick for e. So recall that we found that if you had y is equal to e to the x, the derivative of that is just itself, e to the x. But if x was a different function than just x, maybe g of x, so x squared, square root of x, whatever. But if it was in this form, we would have to use the chain rule. And so remember, the chain rule said that we would take the derivative of the outer piece, which is e. And so derivative here, oops, thinking e and writing e. So the derivative of y with respect to x is the derivative of e, which is just e, of the inner. So the inner piece stays the same, g of x, times the derivative of the inner, which is the exponent g of x. Okay. So let's go through here and take the derivative, just that was a reminder. And so we're using the quotient rule. And the quotient rule says we need to take the derivative of our numerator. And I'm just going to write that we're taking the derivative of that and not take it right now. So d dt all times t e to the t plus 2 times the derivative of the denominator, not the derivative of the denominator, just times the denominator, e to the 4t plus 3, plus our numerator, which is t plus 2, times the derivative of the denominator, so d dt of e to the 4t plus 3. And that is all put over our denominator, e to the 4t plus 3, quantity squared.
Professor?
Yeah.
Would it be minus instead of plus since we're using the quotient rule?
Yes, thank you. You're right. Thank you so much. Minus, because we're using the quotient rule. It's a product rule. We use the plus. Okay. Thank you for chiming in now and not wait until the end when we're like, oh no, and I have to go all the way back. So let's look at the derivative of the numerator first. And with the derivative of the numerator, unfortunately, we have to look at the product rule because we have this t times e to the t. So that's the derivative of the first. So d dt t, I know this is getting tedious because I'm writing it all out, times the second e to the t plus 2. I'm going to call that. Okay, so product of this first piece, not plus 2 yet, plus the first, which is t, times the derivative of the second, d dt of e to t. So that's just the derivative of this product. Plus, we still have to take the derivative of 2. Well, that's 0. So that's okay if I take it right there. Times the denominator. So parentheses e to the 4t plus 3 minus this numerator, t e to the t plus 2, and the derivative of the denominator. Okay, so taking the derivative of e to the 4t, So taking the derivative, this is the chain rule. So taking the derivative of the outer, which is e, of the inner, which is 4t, times the derivative of the inner. So the derivative of 4t, the exponent is 4. Plus the derivative of 3, derivative of constant is 0. All over this denominator, e to the 4t plus 3 quantity squared. Okay, so break it down. Derivative of t is just 1. So this is 1 times e to the t plus t. Derivative of e to the t is just e to the t. All of this times our denominator, e to the 4t plus 3, minus the numerator, t e to the t plus 2, times, and we already took the derivative of this, let's just write it as 4 e to the 4t, all over the squared, e to the 4t plus 3, quantity squared. I'm looking to see if there's anything that we have in common in the numerator and the denominator, and I don't see anything that we really have in common. So I would probably just leave it like that. We could distribute combine like terms, but I would leave it like this unless they asked you to go further. Let me just pull everything and then ask if there's any questions on that. Okay, so I'm going to go a little further because it looks like that it did go further. And so let's distribute. We need to distribute here. So this first kind of grouping is 2 terms times 2 terms. So we're going to need to distribute. So we have, and let's go back here and let's just review really quickly rules of exponents. If you have the same base, I'm noticing I'm going to have the same base e here, and we have the same base and there's multiplication, we add our exponents. And so when I distribute e to the t times e to the 4t, we have the same base e, so 1t plus 4t, that's going to give me e to the 5t. And so I have an e to the t times 3, so this is plus 3 e to the t. And now I'm going to go to my next term in my first parentheses and distribute it. So I have t e to the t times e to the 4t. So that's plus a t, and e to the t times e to the 4t, same base, add our exponents, we got the e to the 5t. T e to the t times 3, so that would give me plus 3 t e to the t. Okay, so now I'm going to go to the second grouping, and when I distribute, I'm going to distribute actually this 4 e to the 4t, but I'm actually going to carry the sign there because I have to distribute it anyways. So I might as well carry negative 4 e to the 4t. That would make this a plus then. Plus. So if I carry a negative 4 e to the 4t times t e to the t, well, negative times positive, so now it's actually a minus right now. So that's 4t e to the t times e to the 4t, we said was e to the 5t. And now carry the negative 4 e to the 4t to the 2. So negative 4 times 2, so that's negative 8. And that would be e to the 4t. All over that denominator, quantity squared. So let's look and see if we have any like terms, and I notice we do. So like terms, you have to have the same variable raised to the same power. And so if I'm looking for anything that has e raised to the 5t, this t e to the 5t won't work because this one has the t in here. So that doesn't work. So let's go and see if there's anything without the t, but e to the 5t. Oops, didn't mean to do that. And do I have one? No, I don't. So let's bring down the e to the 5t there then. That's the only term by itself. Let's look and see if there's any terms that just have an e to the t. And there's not. So let's just bring that down too. Here's one where we have t e to the 5t minus 4t e to the 5t. And so those are like, and that will give me minus 3t e to the 5t. And it looks like the others don't have anything in common. So just bringing down this 3t plus 3t e to the t minus 8 e to the 4t. All over this e, the 4t plus 3, quantity squared. So I could manipulate this so that I can pull out some e to the t's, but I'm not seeing that that's gonna simplify and cancel out with anything in my denominator right now. Let me just pause for a sec.